Okay, we are going to look at the remaining methods. We have add at a given index, a value. We have remove the node at a given index, and we have get the value at a given index. All three of those require us to traverse through the list in some sense to that given index. So before we do those, I'm going to look at this, look at and write this node at index, which will return the node that points at a given index. So if I look at what I want that to do, so it's node at index. So let's go ahead and write the header over here. And it's going to be a private method. We're not going to be able to call it from outside of the linked integer list. So I'm going to put it here, private, right above to string. Private, it's going to be type integer link node. We're getting an integer value as a parameter. Sorry, it's called nodeAt. We have an integer index coming in as a parameter, and then we're going to return something. So for now, just return null. Okay, I want to go back and look at what this is doing on paper. So node at index, we want it to return the node that points to a given index. So here's my list. The front points at 8, which points at 7, which points at 6, which points to null. So the first thing we need to think about is, what are the indices here that are okay to utilize? We would need index is going to need to be between what? Certainly greater than or equal to 0, because it can't have a negative index, but it would also need to be less than size. Turns the node that points to a given index. But there is no, so here we have indices 0, 1, and 2. There is no index over here, even though there's a pointer there. There's no index 3 that we can put there. So or do we want that to be able to point there? So that's the question is, do we want to be able to return that last pointer? Not sure. So let's pretend like we don't, and then we'll see if it runs into any problems. So if index is less than 0, or index is greater than or equal to size, we're going to throw index out of bounds. And then what's going to happen? Otherwise, so usually with linked lists, we have to kind of take care of the front case first. So if my list just contains the 8, or even if it doesn't just contain the 8, if the index we're looking for is 0, then we want to return this front. So let me think about what happens if we start off with a current equaling front. Then I want to run through a loop for I equals 0. Let's see, is it less than or equal to index? So less than or equal to index? I think it's less than index. And let's look at y. Second here, I less than index. So let's say I'm looking for index 0. The node at index 0. Then we would want to return front. So we wouldn't want to get into this loop at all. And so I could say equals index here, and that loop's going to run once. What's going to happen in this loop? In this loop, we're going to advance current. Current equals current dot next, and then we're going to increase I. Oh, we don't need to increase I there because we can increase I up here. So if we had less than or equal to index here and the index that we're looking for was 0, we're going to run this loop once and we're no longer going to be looking at the front. We're going to be looking at front.next, which will be bad. So current equals front for I equal 1, I less than index, current equals current.next, and I will advance, current will advance. Suppose that our index that we're looking for is 2. Change colors here for a second. If index is 2, I is going to start at 0. We've got our current here. When I is 0, we're going to run this loop. Current is going to equal current.next. It's going to point there, and I is now going to be 1. Current is I less than index? Yep, still less than 2. So current's going to equal current.next. It's going to be that guy. I is going to advance. Current I is now equal to index. So after this loop, the link that we want would be pointing at index 2, and we can return current. This is really hard to do strictly from code. What'll happen if you try to just code it without the logic? Oftentimes you'll be one short or one too far, and you might get some index out of bounds exceptions, or the program will just crash, or you'll returning the wrong node. You'll skip stuff. Things weird happen. Things can happen that are weird. Okay, so I'm gonna jump back over to our code. Maybe I can keep them open at the same time. Push that over a little bit. Let me strip this down a bit. Nope. Okay. Just make it smaller. So much easier with a whiteboard, let me tell you. Well, it's not working very well. There we go. So private integer link node at index. We're coming in and we're saying if index is less than 0 or index greater than or equal to size, we're going to throw new index out of bounds. Exception, it's going to give me an error. Oh, I guess not. But okay, and then we don't need an else, because if that is true, then we're out of this method already. Now we're back in here and we're going to say current integer link node current equals front. For integer I starting at 0, I strictly less than index I plus plus. Advanced current. And then when we get out of that loop, we can return current. So that's done. I'd like to test it. I can't test it from my client because it's a private method. So I can kind of cheat, and I can cheat, but I can go back in and I can change it to public. I'm gonna just put a comment in here. Excuse me. Oh, excuse me. Excuse me. What am I doing? Okay. This guy return private method. I don't need to say it's private. Returns node that points to given index. Indexed node. So keep in mind that this index, this nodeAt actually returns the thing that's pointing at the given index that we want. Okay. So to check this, I'm gonna make it public temporarily, and I'm gonna go back to my new client. And so let's see, if I wanted to test this, I could say, okay, system.out print line. I want to print, it's going to be list1 dot node at, so let's look at the node at index 0 dot data. So that should be the 8, because that's what's at the front of our list. So that should print the 8. It does. I'm going to go and just change that to a 1. That should print the 6. It does. I'm going to change it to a 2. Should print the 9. It does. I want to change it to a negative something. It should throw an index out of bounds. It does. I want to change it to a 3, and it should throw an index out of bounds. And I just, I'm testing the different scenarios there. Oops, I have an extra parenthesis. To make sure that they work. And primarily it's, the front and something in the middle and something at the back. I don't know that I need this there anymore. I think in fact, I think I'll just, take it out, but there's no reason to keep testing that. We're going to go back and we're going to make it private right now anyway. So then I wouldn't be able to call it from the client. So I'm going to go back to linked integer list and we're going to make this private. And maybe I'll just say here, private method. That returns node that points to given index node. Okay. So I want to write that one first because if we shut this down, when we go back over here, we can see that if I want to get something in a given index, then I need to be able to call that. If I want to remove something in a given index, I want to be able to get to that index. And if I want to add something in a given index, I want to be able to get to that index. So this nodeAt can save me some time. I think there's one more that's that could use it. Let me think, which one is it? The add could do it. We could just, yeah, we could add, because we're adding there at the end. So we know that index at the end is size -1. It could create some issues if the list is empty. So I don't know that we need to go back and change add. I wish I knew how long this video was. I think get would be very quick at this point. So let's just try get. And I think I would put get right up after size. So let me just hold off on, here's my nodeAt I just wrote if you need to pause. And I'm going to go up to wherever size is. There it is. And right after size, we're going to go public integer get integer index. Let's return 0 for a second. And this method returns the value at the given index, and it will throw index out of bounds exception. Okay. So I go back to my paper for a second, which I closed, which is irritating. And we think about what get's doing in terms of our list. So we have our list with our node at 8, and then, I don't know, 7. Let's make it 6, and then 9, I think. Oh, what happened here? It's not good. 6, and then 9. Yeah, I'm gonna pause. I don't want to deal with this. So I'm gonna not do that right now. Not sure why that's happening. And instead, I'm going to end this video. We'll do get in another video.